Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. This is episode 9.5 on the quadratic formula, and where we ask the essential question, how can you derive a formula that can be used to write the solutions of any quadratic equation in standard form? Okay. So previously, the last lesson we covered was completing the square. And that works for just about anything, but it is kind of cumbersome, and you have to deal with square roots of things that maybe aren't perfect squares and all. So I'm going to start with a clean slate here. I'm going to try and do this just off the cuff. The standard form of a quadratic equation we know is ax squared plus bx plus c. Okay, so, and of course it has to equal 0. So we know that one thing when we're completing the square that we cannot have a coefficient out here at x squared. It has to be just a plain x squared. So we have to divide everything by a. And that's going to leave this. Okay. Then we know that we kind of have to open up this part of the equation in order to complete the square. We subtract this from both sides. So if I subtract this from both sides, it's going to look like this. Voila. Okay, so completing the square means you take half of this, and I'll do this in a different color on the side here. So half of b over a would be b over 2a. And then we square the whole thing. So that's going to equal b squared over 4a squared. Right? So I'm going to add that to both sides of the equation. Plus, let me do this in an even differenter color as to not confuse us. Okay, now what did we do next? We took the fact that this was a trinomial square here and we factored it. So I know this is going to come down to be x plus, and then the square root of this, which we already know was going to be over this part, b over 2a plus b over 2a quantity squared. Now over here I have to do a little what? Conversion for this factor, for this term to have common factor. So negative c over a, I want to multiply by what? 4a, right? 4a times a will give me 4a squared. So this becomes 4a squared, and then up here I multiply by 4a. So this becomes 4ac. Okay, so I'm going to rewrite this here as negative 4ac over 4a squared plus b squared over 4a squared. Okay, so I've just rewritten this now to have equivalent denominators. You know, to have the common denominators here, but these are equivalent fractions. So I can now simplify the right side, and I'm going to do it this way. I'm going to put b squared in front, so I don't have the leading negative. B squared minus 4ac over here, all over 4a squared, common denominator. Okay, with me so far? Now, what did we do next when we went to when we used completing the square to solve? We take the square root of both sides, right? So I'm going to take the square root of both sides. So the square root of this side, of course, is just going to be x plus b over 2a. On this side, plus or minus b squared minus 4ac. And then down here, of course, this has a square root, so I'm going to just use that, 2a. Okay. Now we just isolate the x. So I'm going to go ahead and subtract b over 2a from both sides. So it's negative on this side, b over 2a plus or minus all this stuff, b squared minus 4ac over 2a. And since I have a common denominator here, I can just easily simplify this. So x equals the opposite of b plus or minus b squared minus 4ac all over 2a. And there we have our quadratic equation, where x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I just said this was the quadratic equation. This is the quadratic formula. Okay, this can be used to solve any quadratic equation. Any quadratic equation. Okay, so we're going to use this, and let's move on. That took a little longer than I thought. Okay, so we want to solve 2x squared minus 5x plus 3 using the quadratic. So remember, this is ax squared minus 5, minus bx plus c. And I'll write the quadratic formula out for you here. Okay, so now it's about really just substituting and plugging in. But really be careful substituting, because like these negatives, it's really best to just substitute straight ahead everything and then simplify. Remember, b is negative 5 here. This should be a plus here, down here. X squared plus bx plus c. So b is negative 5. Okay. So x equals the opposite of b, which was negative 5, plus or minus the square root of b squared, which is negative 5 squared, minus 4 times a, which is 2, times c, which is 3, all divided by 2 times a, which is again 2. Okay, so x equals the opposite of negative 5, which is 5, plus or minus. Now, be careful in here. This is 5 squared. Negative 5 squared is 25. I'm going to do this in one step. So 25 minus 4 times 2 is 8. 8 times 3 is 24. 25 minus 24 is 1. All over 4. So x equals square root of 1. Let's just say x this way. Okay. So x equals 6. 5 plus 1 is 6. 6 divided by 4, which is 3/2. Or x will equal 5 minus 1, which is 4, divided by 4, which is 1. So our two solutions, x equals 3/2, x equals 1. Okay, so it's a matter of just substituting and simplifying. I'll skip the word problem for now. We'll work on this one in class. And the discriminant. Now, the discriminant is b squared minus 4ac. It's the part of the quadratic equation that's under the radical sign. It's called the radicand. B squared minus 4ac all over 2a. Okay, but this part here is what we call the discriminant. If it's positive, we're going to have two square roots. We've already seen this when we were solving solutions using square roots, taking the square root of both sides a couple lessons ago. If it's equal to 0, then we'll have one solution, because now it's going to just, the vertex is going to be on that x line. And then if there's no solutions, because negative numbers don't have square roots, so this has no solution. And when you're doing this, when you're using the quadratic formula to solve quadratic equations, if you get to this point where you realize that this number out here is negative, you can just stop and say no solution. At that point, you're done. So that's kind of a nice thing to know. Determine the number of real solutions here. I'll just do the first example here. B squared minus 4AC, right? That's our... Okay, so B squared is 8 squared is 64. 8 squared is 64. Minus 4 times A, which is 1, times C, which is negative 3. Negative 4 times negative 3 is 12. So this is the number of real solutions. There's 2, because that's a positive number. And I don't want to waste any more time just doing these examples. Those are pretty straightforward. Just make sure you know that B squared minus 4AC is that discriminant. Find the number of x-intercepts. Again, they're asking you the exact same question. The number of x-intercepts is the same thing as the number of solutions. Okay? Or sometimes they're going to refer to these as zeros. Or they call these roots. All the same thing. So you would do the same thing, use that discriminant, B squared minus 4AC. Okay, so this is we're almost to the end of this chapter here. Let's just do a quick recap of what we know about solving quadratic equations. Factoring, this goes back to 2 chapters ago. If you can factor it, that's the best way to do it. Graphing, really using the calculator, not by hand. It says may not give exact solutions, but if you're using a graphing calculator, it will, but it's still going to round. Calculators do round, so that's true. Using square roots, a few lessons ago. Completing the square. Like it says, it may involve difficult calculations. We don't really use this one a lot other than just a bridge to the quadratic formula because it can be used for any. It says takes time to do calculations, true, but it's really just a matter of simplifying some expressions, but it does give exact solutions. So the quadratic formula, which we just did. So that's an overview of all the different ways to do this, and you're going to be responsible for all of them probably. Okay, that's it for now. We'll see you in class next time. Have a great rest of your day.